Today we're going to talk about perimeter, area, and volume. And these are subjects out of geometry. And before we get too far into the lesson here, I would like to try to explain what these things mean a little bit, these words. First of all, if you look at the word perimeter and break it into two parts, you have the prefix peri. And if you think of periscope, means to look around. Perimeter, peri means around. Peri means around, and meter means to measure. So perimeter is simply the measurement around a figure. And there's a key word that goes with perimeter that I like to use, and that's the word surround. You're going around the figure, so I use the word surround to go with perimeter. Now, area, on the other hand, is the key word with area is to cover. Is to cover. Now, I'm going to come back and talk about these in just a little more, just a moment. But area means to cover. Volume implies that you should fill. Okay, now let's look at the key words. What are you going to surround a geometric figure with? Let's look at a rectangle, for instance. We need to get around that rectangle. What should we surround it with? Well, the answer to that is you surround it with segments. And you can start one of the segments here, and then you just lay that same size segment all the way around the outside of that figure, and then you count the segments. So in this particular case, the perimeter would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those segments. Now, you also have to make another choice here. How big are the segments? Well, some of the segments will be only 1 inch. Some of the segments may be 1 centimeter. Some of the segments may be about 3 feet. Let's go to that first, a yard. Or a little bigger than that, they might be a meter. If you have an unusually large figure, perhaps the length of that segment might be a mile. So you have to choose how long the segment is going to be, and then you lay that same size segment around the figure to surround it. And when you count the number of segments, that is the perimeter. When we look at area, we're talking about covering. And let's take the rectangle again. And mathematicians a long time ago decided they would cover these geometric figures with squares. They would cover them with squares. So they decide, just like the kind of segment over here, they decide on a certain size square to use, and then they start putting those squares over the rectangle to cover it. And then when you counted the number of squares necessary, that was your area. So for instance, if I took a square that was this size, well, you have to presume something here. Those are all supposed to be the same size. Then the area of this would be 1, 2, 3, 4, 5, 6, 7, 8. Just count the squares. Now we're going to find later on that there's formulas that will help us count these things. We don't have to physically go through and count them one by one. We will be able to have a formula that tells us how many squares or segments there should be. When we talk about volume, that applies to a three-dimensional figure. And this one's a little more difficult to draw, of course, because it's 3 dimensions. But we're going to fill that figure. And what do you think we might fill it with? gotta have something that takes up space because we're gonna fill this up. And if we just think a little bit of geometry, we're doing this with segments, we're doing this with squares, our next step might be what? There you go, good for you, perfect. Fill it with cubes. So you decide what size cube you want, and then you just start packing them in there, layer by layer by layer. And if you count those cubes, the number of them that you use is the volume. Now, I'm not going to attempt to try and draw this thing full of cubes, so you need to use your imagination a little bit here. But we're going to take a cube, I'll put one in here just to show you I can do it if I want. There's a cube down in the corner, and we would just fill up that first layer and then have another layer and so on until we're right up to the top and it's now full. You filled it, and the number of cubes in there is the volume. Now, let's go back. I mentioned that we have a formula for doing these things. Let's go back and see what that formula is. If we're dealing with perimeters, usually we
I'm going to
use
keep
the
that
letter
thumbs up
P.
there.